Okay, here we go, heading into another circle theorem, and this one's quite interesting, I think. For any two intersecting chords, intersecting means that they just they cross at point X, and a chord is just a line in a circle, as we know. We know that AX times CX is equal to BX times DX. And what that means here is that if you take the line AX and you multiply it by CX here, so that length times that length is going to be equal to that length times that length. And it seems a bit strange with no sort of proof given for that. But it's quite straightforward, I think. If we just have a look at the invisible line or chord BC, we can see that this angle here is equal to that one there because they subtend from the same chord. They subtend from BC. And equivalently, if we were to do the same from the chord AD, we can say then that these two angles are equal as well. So that means if the two angles in red are equal and the two angles in yellow are equal, that means the two angles in the middle here, AX, would be equal as well. And therefore we can say that the triangles ABX is similar to the triangle CDX. So if they're similar, then we can write that the following. We can say that AX divided by BX, so that's this line divided by that line, is going to equal DX divided by CX. I'll write CX over, oh no, I can't do that, I can't do CX. It's got to be DX on the top, hasn't it? So DX divided by CX. So then by just cross multiplying, we can see that that implies that AX times CX is equal to BX times DX. And that's what we were trying to prove. Quite straightforward, I think. And the first worked example here is to find the angle A in the diagram. So how do we use all of this stuff? First of all, the first thing I would include here is that is a right angle. And we know that because it's a radius meeting a tangent. And we also know that this length is equal to this length, and these two are equal from the theorem we talked about before in the previous video. So now we can use the idea of these similar triangles. Then we can say that therefore this angle here must be 65 degrees as well. And so therefore this angle here and A would be equal. And this angle is found quite straightforward. It's going to be 90 minus 65, which is 25. So 25 degrees is this angle, and therefore is A as well, because these two triangles are similar.